us, and yeah, also a warm welcome to all the people listening to our talk about mastering the industrial IoT with Apache StreamPipes. So first of all who we are. So we are Dominic, Patrick, and me, and we are three researchers at the Research Institute, the FZI in Karlsruhe in Germany. And we started developing StreamPipes around 2014. And last year in November, we joined the Apache incubator. And here you can also see a picture of us last year at the ApacheCon, where we started to decide to move to the Apache incubator. And a lot has happened since then. So we are the PPMC members of the project. And you can also see our Twitter handle and also go to the our homepage and documentation. So they will also find more information about the project. Then first, coming to the agenda. So we'll start with an introduction into the industrial IoT in Factory 4.0. Then we will give a brief overview over StreamPipes and the different functionalities that we have. And we will directly have a demo where you can see the system and how we were working with sensor data. So we are focusing both on sensor data like temperature sensors or other sensors that are common in industrial settings, but we can also process image data. Then we will explain a bit more about the technical details of the system. So what kind of services we are using under the hood, and also talk about how you can extend StreamPipes and add new analytical algorithms into the software. And in the end, we will conclude with the roadmap of upcoming features that the community is currently developing. So first of all, the industrial Internet of Things. Here you can see a sample production line. So usually in industrial settings, you have a lot of different heterogeneous sensors and protocols and formats. For example, on the left, there's the robot operating system, which can be used to connect to robots. And here we have, for example, a gripper force that is monitored. Then we can also have images, so they can be sent over MQTT or other protocols like REST. Then there are also often old machines. So Modbus is a standard which is already quite old, but commonly used in this field. And so you have a lot of different kind of information which is provided over Modbus. Then there are also a lot of different PLCs which are used to control the machines. And there you can also get a lot of sensor data from your production line. And there can also be third-party systems like an ERP system or other systems which are used to control the flow of a production line. So there are already quite a lot of libraries and frameworks which help developers to get this data out of the systems. For example, with Apache PLC4X, you can read data directly out of those PLC devices. But still, a software developer has to implement individual solutions for the individual systems. So you have a high development effort. And also domain experts, which often work in this domain, do not know how to program those connectors themselves. This is why we provide in StreamPipes a way for domain experts to use a graphical user interface to connect to heterogeneous data sources and get this data onto a message broker, for example, on Kafka or on an MQTT broker, and then start analyzing it. Patrick will also show this later in the demo, the way you can see how data is getting into the system. And this can also be done with little or less technical knowledge. Then a brief overview over StreamPipes. So what is StreamPipes? So StreamPipes is an open source industrial IoT toolbox that enables non-technical users to connect, analyze, exploit IoT data streams. So we have different modules in our system to first connect data. Then we have a pipeline editor that can be used to perform analytics pipelines on those data streams. And the results of those pipelines can be shown in dashboards, for example. Then recently we have released a data explorer that can be used to also explore historic data. So you can store it in a database and visually explore the data, or you can define rules and notify someone. For example, if something is going wrong in your machine or in your setting, you can send a notification to a service technician, for example. So how does this work? So in the beginning, we always have data sources. So those can be from those different data sources, can be a Kafka cluster, but it can also be those industrial protocols like PLCs or OPC UA or REST endpoints. And in the first step, you have to connect those machines, those sources. Then we have an algorithm toolbox with simple algorithms, but also more advanced algorithms. So for example, users want to filter out data or detect patterns in the data stream or apply machine learning algorithms on this data. Those algorithms can run on a standalone machine or can also be deployed on the edge or can run in a distributed setting like, for example, Apache Flink. To deploy the system, we offer multiple possibilities. So you can run the system on Linux, on OS X or Windows, and you can also run it on ARM or x68 architectures. And we also provide an installation for Kubernetes with Helm charts. So you can also deploy to a Kubernetes cluster. And then the goal of users is to realize use cases using the software. So for example, continuous monitoring or calculating live KPIs that should be monitored. Or you can also wrap machine learning models in those reusable components and apply them in multiple scenarios. So typical StreamPipes use cases are first continuous asset monitoring. So you connect different assets and build a live dashboard to get insights of the current state of the system. Then you can also use the different algorithms to calculate live KPIs to get feedback of how your production line is performing and monitor this over time. We also often use it to collect training data for machine learning. So when connecting the data, you can also pre-process it and harmonize it and store it for later offline training, for example. And then those models can then directly be integrated into the system to apply it on new data. And you can also, for process and product quality inspection, so you can detect time-critical situations, for example, with complex event processing or rules that are applied on data streams, but you can also use machine learning algorithms and perform predictions on your data. And both scenarios will be shown later in the demo. Here you can see a brief overview over our architecture, what user sees in the graphical user interface. So a user always builds this execution pipeline, which is shown on the right. So we have multiple data streams. In this case, we have two different data streams, which are produced by StreamPipes Connect. And they produce a continuous data stream and harmonize it on our internally used message broker. Then users can select via drag and drop different algorithms and analyze this data. So those are configurable functions that can be added onto the pipeline assembly via drag and drop and be connected. And then users can configure them, for example, transform the data or filter out certain situations. And once the processing is done, this data can be sent to data sinks. So those are, for example, databases or dashboards, or can also be third-party systems like Kafka. And you can also send data back to machines, or for example, in this case, we have a UR robot, and you can send a signal back to this robot, which performs an action based on the calculation that is done in this pipeline. Here we have a brief overview over the StreamPipes IoT toolbox. So first of all, we have Connect on the top left, where we already have a lot of different adapters for heterogeneous protocols and formats that can be used directly in the graphical user interface and configure them. And based on these configurations, an adapter is automatically instantiated to connect to the data source and provide a data stream. Then we have a live dashboarding feature where you can build live dashboards. Also, we have an internal notification system, but you can also use other notifications, like, for example, Slack, where you want to send a notification to. And we have the newly developed Data Explorer, where you can explore data. But this is just a brief overview. Next, will Patrick show you the system in a live demo.
You need to give me the rights to share. Yeah.
Stop
Thanks.
sharing.
Yeah, perfect. So if you see my screen, everything's good. Okay, so you see my screen?
No.
Yes, we see your screen.
We see you.
Perfect. Okay, perfect. Thank you. So what you see here is a StreamPipes instance running currently in our office. And basically, once you're logged in and got it set up and running via Docker installation, you see this kind of home screen. So currently, you get a brief overview of how many pipelines are created and already running. You see an overview of already installed pipeline elements and our already mentioned modules. So as a kind of first thing to do is to get the data into the system. And for that, and because we're talking about IoT, we thought, hey, why not look at a more or less realistic IoT setup? So what we got here is Factory IO. It's a simulator for factory settings and deployments. So what we see here is just a simple basic sorting machine. So if I started, what it's doing, it's receiving packages of different sizes, and it's sorting the packages based on their heights. So the larger ones go to the right, the smaller ones then go to the left. And as I said, this is only running at a computer in our office. However, it's controlled via a real Siemens PLC, a programmable logic controller that is hooked up to the simulation, and it's receiving the signals and the inputs of the sensors and then forwarding it to the controllers on the output. So what we want to do and what might be interesting is just get a simple count. So maybe the question is how many large packages are currently received, or how much time does it take for one of the larger ones to leave that kind of area over here. So if we switch over to StreamPipes, the first thing to do to get this data stream into the system is go to StreamPipes Connect. And StreamPipes Connect is essentially a data marketplace where we provide various connectors to various different data sources. So ranging from Kafka, Pulsar, classical HTTP REST-based data sources, MQTT, however, also via PLC4X, an adapter to connect to this kind of PLCs that we're currently looking for. So we can open that connector, and here we need to enter the address of the PLC. So if we take a look at it, it's this one. Just remember. 33. We can set a polling interval. So let's say every second I want to poll it. And then we got various options here, how what kind of fields we're interested in. And here because we're lazy, we can simply say we want to import a file that is provided by the PLC developer. And it's containing the information of what kind of fields are actually in that kind of register. So then in the next step, the system, based on the description, receives the schema. This is kind of dependent on what kind of protocol you're interested in. So for example, if you connect to Kafka, we might not know the schema in advance. So we pull some sample data into the system in order to guess the schema and provide the user a feedback of what the schema might look like. So here, in this case, in this example, we receive the various input sensors here, and we can also manipulate the schema at that stage before even connecting the data source and sending data to our internal message broker. So for example, we could add a timestamp because the PLC does not offer a timestamp. We could also add some static value to the event or mark some fields that we're not interested in. So in that case, we're finished. So let's say we want to give that adapter a name. Just give it PLC and start it. Then the adapter gets instantiated and it's consuming now live data from the actual PLC. So we see the Boolean values changing over time. So this is the first step. And now we can switch over to the pipeline editor. And what the pipeline editor is basically what Philip already mentioned, is where we connect the individual data streams that are now available to the system with a rich toolbox of data algorithms or processes, and with a goal to either send the data out into a third-party data sync or to store it in an internal database. So for this example, we use the just created PLC adapter and switch over to the data processors. As you can see here, there's a large variety of different options. But as said in the beginning, we're interested in counting like the larger boxes. For that, we can use the Boolean counter. And via dragging and dropping and connecting the elements, we're just simply building up and creating the pipeline. So here we see a selection or a way to configure a processor in a way that serves the purpose for our analysis. So here, for example, we can select the relevant input sensor field. So there are various ones here. And what we are interested in is the high sensor. So if we quickly switch back to the factory setting, the high sensor is basically the one that gets triggered once there's a large package leaving to the right of that kind of simulation. And we want to say, okay, once that switches from false to true, we receive a large package. So, and we just simply want to visualize it in a dashboard. Just give it a name. Let's say counter large. And at the same time, we might be interested in actually calculating how long it takes between two sensor measurements, for example, to get this kind of process time. So therefore, there's another data processor. Here in this case, it's called measure time between two sensors or signals. So you can simply connect it again and select the various sensor fields. So in that case, it would be the right entry and to the point where we exit that kind of system, it's here. And let's say we want to get the information in seconds. You can also create a dashboard for that. Time. And now we're done with the pipeline, everything's set, and we can save it and give it a name, just demo 1, for example, and set we want to start it. So what's now happening in the background is that all the configurations that we just provided as a user are sent to individual microservice containers that are hosting these algorithms. And they're now getting invoked by that request starting in the background. So we can simply switch over to the dashboard. Here I already prepared another one with sample data just to get a brief overview. And we can add a new visualization. So here what we see is one visualization for the counter. So we just simply say we want to have it as a single value widget. And we want to select the counter for the large packages. And we want to also add the duration, let's say as a gauge. Also give it a new name, let's say duration. Specify some range, so between 0 and 2. And we can even modify like the coloring and stuff. Okay. So once we're happy, we can save it. And we get the visualizations here. So currently we're received 11 large packages. So if we switch over and see maybe a couple of runs here from the larger packages going to the right, for example, here, we get the increase of the counter value. And also you can see here the duration time. Okay, so much for sensor data. We also provide ways to work on image data. So here with a filter input stream already connected to a camera that is receiving images from a camera that's currently facing downwards in a box, in the logistics box, and it's filming industrial filters. So for example, here every 2 seconds we receive a new image of industrial filters, and let's say we want to detect the position of the filters. So therefore we start the pipeline again by dragging and dropping the filters into the filter input stream into the canvas. And we can use also machine learning models that are wrapped into the data processes. So here, for example, for object detection, we train the machine learning model to detect the filters in an image. So here, the image event field is already provided. And here you see that there are several models already prepared, but we're only interested in the filter one. We can say, okay, we want to save it because that's the one we want to apply on the input stream. So now what we're getting is a bounding box with the positions of the various filters in the box. Then we can use an image enricher that is basically coloring that box around the image and create an overlay. So here we don't have to configure anything. That's due to the fact that we're leveraging semantics in the background to check whether the requirements in the data stream match to what the actual processor is requiring. So Dominic's going to talk about that in the technical deep dive. So we're good to go. And just say we want to save it in a dashboard as well for visualization. Let's say object detection. So now we're done with the pipeline. Can save it, give it a name. So object detection. It's okay. Start it. And again, switch over to the live dashboard. Let's move my thing here. Add a new visualization for the object detection. And just give it a name, filter detection, and add it. So and as you can see here, we now receive like the analyzed pictures with the bounding boxes around the industrial filters. That is only for live dashboarding. I also set up a preliminary set up a pipeline that is saving data into our new beta feature, the Data Explorer. So just to give you a glimpse on that, Philip already talked about it. It's for the historical data analysis. So sometimes you're not only interested in receiving the live data, but maybe you're interested in what's going on like the last couple of minutes, or here 15 minutes, or for the day. You can zoom in, just take a deeper look on what was going on at a particular point in time. Maybe there was some outages and you want to check that, and maybe you want to compare also the individual values here. So here, then we can go back to the pipeline editor, and that would be it for the demo. So now we could just go on and model new pipelines, take a look at different kinds of input streams, and send them over to third-party systems as well. Maybe one small thing to note, StreamPipes is designed in a way that it's extensible at runtime. So if we go down here, you get a section where you can install new pipeline elements. As said, they're wrapped into these kind of microservice representation. So you can also just start up, once developed, start up a new container. The container is automatically registering with the backend, and you can look for newly available pipeline elements or uninstall already installed one, and yeah, thereby extend your system. So with that, I would switch over to the slides.
Right, so let me just share my slides again. Okay, can you see my slides? All right, so now after this quick demonstration by Patrick, I'd like to go into technical details and tell a little bit more about how StreamPipes behaves under the hood. So if you look at the architecture from a very high level, you see something like that. So in the end, if you look at the right-hand side, there's usually some data source, which could be like a machine or some sensor that you would like to connect. And for connecting different data sources, we use an adapter library that Patrick has just shown called StreamPipes Connect, which provides several adapters to easily and quickly create new adapters. And once data is connected to different machines or other data sources, there's a transport layer where we use a message broker to just integrate data coming from heterogeneous and different sources. For the message broker, we use Apache Kafka, but more on that later in a second. So, and in front of the message broker is like a set of pipeline element microservices. So in general, each data processor that you have seen in the pipeline editor is encapsulated in form of a microservice that provides the processing logic, so the runtime on the one hand, but on the other hand also provides a description of the algorithm or the data processor or the data sink that describes requirements pipeline element needs for an incoming event stream to provide. And that is used on the UI layer to simplify pipeline development, to also avoid modeling errors and so on. And this is being done basically by the pipeline management, which is like the core of StreamPipes, which communicates with the web-based editor on the one hand, and does consistency checking of pipelines, for instance, and also trigger start of pipelines, and then communicates with these pipeline elements microservices in the background, and starts and stops and invokes these pipeline elements. So let's start now with how to create new data sources for StreamPipes using this connect tool we've just shown. So in general, data is provided by like some protocol, like MQTT in that case, and in this case, it's also just a plain JSON message that is being provided by the event source, in that case, the machine. But it could also be, of course, some binary message or some protocol like Apache Kafka, or some very specific adapter, like if you would like to connect some traffic cameras or so on. We also provide some more specific adapters, but also very generic protocols and data formats. So, and this temperature sensor here now represents the data source, and then users create pipelines as you've just seen. So how do we connect data based on these protocols? So that is generally being done by a worker architecture. So what you can see here is now like the block of a StreamPipes Connect worker, and that is split in a description on the one hand and a runtime on the other hand. So now let's talk a little bit more on the description layer here, because that's one of the core features of StreamPipes that is being used to improve modeling of pipelines from a user perspective. So in general, there's a data model behind each data adapter that describes the event stream. So let's say we have an event stream, very simple, that provides a timestamp, has a machine ID and a temperature value, which is part of every event here. Then there's, of course, some schema description where we model, of course, the data type. In that case, temperature is being modeled as a double value. The runtime name that is in this JSON example now, temperature, but also provides the semantic type so that we later know this is actually not just a number, but it's a temperature value. And that can be used later on to also connect this data stream to very specific data processors, for instance, that do temperature conversions and so on. So that is being reflected here in the event schema, but you can also model more things, which is not necessary. So you can start with a very simple description and extend it later, but in general, you can also model things like event quality. Let's say you have a frequency of a data stream. So one common example is if you have an accelerometer sensor measuring acceleration, and on the other hand, you have some activity detection processor that calculates the current activity if you're running or if you're walking, for instance. So in that case, you'd need some minimum frequency in order to produce results that actually make sense. So frequency is something you can model here, or also latency if you have some latency requirements for, or provisions from this data stream, but also a measurement unit. So in that case, we model the temperature value in form of a measurement unit, which is in that case measured in degrees Celsius. And these metadata descriptions are accompanied by several user configurations. So that's what we have shown in the POC demo, in the first demo, where we provide some IP where you can connect to the data source or the port, or in the MQTT example, also the topic. That's the description layer basically, and then there's also a runtime layer, which then connects to the data stream and internally produces data or an event stream that is forwarded to the transport layer, which is in general exchangeable. So you can use MQTT, but in most cases, and also in the standard deployment we currently have, we use Apache Kafka internally as a message broker to forward events. So, and in case users change any parts now of the incoming event, so you can basically define edge-based transformations on this incoming event stream. So you could say you would like to transform the temperature value from degrees Celsius to degree Fahrenheit right in the runtime here. So then it gets converted on the fly once you connect to data and forward it to Apache Kafka. So what happens now when we start a new adapter? The user clicks in the UI to start a new adapter once it's configured. And then the master component of StreamPipes Connect triggers the worker, submits the user-defined configuration values, and also determines an event grounding, which specifies the protocol, the format, and also like settings like the host name of the broker and the output topic, which is handled or managed internally by StreamPipes. So these are parameters that are selected automatically. We currently support other formats from JSON, also binary messages in case you need more speed on the transport layer, but that is independent from the data format that is selected here in the connection to the data source. So a very similar architecture is being applied for data processors. So if you have things or processors, then also there's again a description layer and a runtime. And each data processor provides a description of input requirements in terms of what characteristics should the incoming data stream provide in order to make it compatible to the data processor. So some examples are shown here, and the example we use on that slide here is a numerical filter. Yeah, basically we just get events from an input stream, and there's a statically defined threshold value of 100, for instance, and an operator, and the events are filtered. So in that case, things like threshold, the operator, and also the property, so the field of the events that should be filtered, are user configurations. So there's a set of supported, let's say, properties that can be used as a user configuration value that are later on rendered in the UI in form of several UI widgets. So if there's like a required text input, you get a text field. If there's a selection, you get a radio button or a slider. And so it is not only statically defined what kind of UI widgets are shown based on the user configuration, but the system also tries to guess in the background based on the metadata we have which component should be shown. So if there's, let's say, an operator where you have a minimum and maximum value, the system will automatically select a slider value instead of like a simple text input. Or if you know which kind of data is being provided here, the text input will be shown in form of a selection input. So let's now move on to the stream requirements first, maybe. So if there is a stream, or each data processor, let's say, defines some requirements for a data stream. And that basically are requirements on the schema level or also on the quality level that I've shown on the previous slide for Connect. So in that case, if you have a numerical filter, this should usually be able to being applied on every event stream or every event that provides some numerical value. So by providing these stream requirements, you get quite a good picture on what can be connected to this data processor. Then there is some concept of output strategies. So in general, we do not want to let users select like the output or so. So probably you have noticed in the demonstration that one goal of StreamPipes is to really hide technical things from users. So because we really try to target domain experts without technical expertise, so we do not want to show them some JSON schemas and give them some very advanced options to modify the output of event streams. So there's a set of output strategies that developers can define once they are implementing a new data processor, like a keep output strategy, so which basically just determines that the output event stream has the same schema as the input events stream. Or you can have an append output strategy that appends new fields to an incoming event stream, and other output strategies that developers can select here. And in the background, the system then, once users model pipelines, decides how an input stream is transformed to some output stream. And finally, there's the concept of event grounding, where we define which protocols are supported by a data processor. So remember, it's a microservice. So there could be a set of different protocols that this data processor can connect to, or different data formats used as an input. Yeah, and so basically in the end, the runtime receives event from Kafka and forwards them again back to Kafka once they are processed by the processing function. Now, having a look at the life cycle of a pipeline element. So in general, once users start a pipeline element, which is being triggered in the user interface, the pipeline management component calls all involved microservices of the pipeline, triggers the start, and then this runtime is being triggered. And the user configuration is again provided by the pipeline management and forwarded here to the runtime. So now we took some time to talk about the description layer. So why do we need such a description layer? So one of the core goals is to abstract technical details from end users and to provide some sophisticated user guidance. So as you've seen, once you have a data stream which you connect to a data processor, the system automatically evaluates compatibility between pipeline elements, and in case these elements do not match, so that some input requirement of a data processor does not match what a data stream provides, you will get some error message like this, and the system tells you this cannot be done, for instance. And in case it works, the system automatically pre-selects like suitable event fields. So in that case, if this component here requires some Boolean field, it automatically selects all Boolean fields. Or if you say there is a requirement on the temperature value, then all properties that also provide a temperature value will be pre-selected, and everything else will be hidden from the user at pipeline development time. So that's like the process. So we use internally some RDF representation of a pipeline element, so that there's in the end a model that allows us to easily determine if two components are basically compatible. So now looking a little bit at the runtime. How does it actually work that we invoke a runtime? So StreamPipes does not provide its own runtime in this sense, but we have a set of runtime wrappers where we delegate pipeline element invocations to that underlying runtime. And there are in general two sets of different runtime wrappers. So first of all, there are standalone wrappers, which are rather lightweight, can also run on resource constrained devices like a Raspberry Pi or so. And there's a plain Java-based wrapper. Then there's a wrapper that uses ZIDI, which is like an engine for complex event processing. So there you can write pipeline elements that do care more about time series analytics, like stateful detection of sequences or patterns and so on. And we are currently in the process of developing a new wrapper for Python, because many users asked us to provide a way to also define pipeline elements using Python. And that's currently under development. So yeah, we can talk about that later also. And then there's a set of distributed runtime wrappers. We currently have a wrapper for Apache Flink, and also like prototypical implementations for Spark and Kafka streams. But we are mainly focused on Flink here right now, which works very well. And I have a quick slide on how pipeline element deployment works when using a distributed wrapper. So in that case, of course, there's a cluster in the end, a Flink cluster, where the runtime is actually being invoked and running. So events are coming from Kafka. Once the pipeline is started, there's a Kafka source, which is part of the wrapper, and a Kafka sink, also part of the wrapper, forwarding data to Apache Kafka. But this aggregation logic here, that is part of the pipeline element that needs to run in the Flink job here. What we do here in that case, so for each wrapper, it's a little bit different depending on what the execution engine actually provides. But let's say the pipeline management triggers the start or invocation of the pipeline element. And in that case, we use Flink's remote environment to move the package jar to the cluster, along with the execution graph, which is generated here by the runtime beforehand. And then in the end, the system executes the Flink job, which is running until the pipeline is being stopped again. So just to give you some more insights into how we deploy pipeline elements that should be deployed to some distributed runtime. All right, there's a few more slides left on how to extend StreamPipes. And there is some code that shows you how to create a new pipeline element. So in general, we provide a software development kit that should ease the definition of new pipeline elements and the implementation. And what you can see here is like how you create this description. So in the end, you first provide some ID of the pipeline elements. You can also ship a documentation and an icon along with the pipeline element. You can define so local. So currently we only support basically this English language, but it's already here in the SDK. Once we extend this to other languages as well, then you can ship language files basically also with a pipeline element. You can give it a category. And so the first step here is that we define a set of supported formats and protocols, which is like in that case the JSON format, and the supported protocol is only Kafka in that case. So then there's the input. So as I said before, we need to define how a data stream should look like that is compatible to this element. So in that case, we simply define a requirement for any property that is present. So there's no specific restriction. but you could now here specify a more detailed requirement depending on the semantic type, on the data type, on the quality, and so on. So next step here is to define user-defined parameters, which could, in that case, it's just a simple text parameter. And as you can see on the right-hand side, this code block here renders in the end this input field in the user interface once you install and use the pipeline element. And finally, you can see here now the definition of an output strategy. In that case, it's an append output strategy. So we append a single event property called greeting, which is the message users can enter here to each incoming event stream that arrives in the processor. So that was like the controller, and now we still need to define the runtime, and that can be done by implementing an interface. In that case, it's called event processor, but it's very similar for things. And then you get 3 different methods here. The first one is on invocation, which is called once the pipeline is started. Second one is on event, which is called for every incoming event. And it also gives you an output collector where you can forward events to the next pipeline element. And there's another method on detach, which you can extend or implement in order if you need to clean up database connections or things like that once pipelines are stopped. So that's like how you define the processing logic of a pipeline element. All right, so we skipped that part for today. There's a GitHub repository from Patrick, which has a little tutorial on how to write new data processors. So that's a demo we showed at ApacheCon a few weeks ago. So if you're interested in getting some first steps, you can either look up our documentation, but there's also this project that guides you through the first steps of creating new pipeline element for StreamPipes. All right, so finally, there's just we have a short, quick glimpse on our roadmap. So currently we are trying to establish or to grow also the community of StreamPipes, and here's some things community members are currently working on. So I already talked about the Python wrapper that is currently under development. And there's some effort where some users are developing edge deployment solutions. So in general, a pipeline does not need to run at a single location, but you can distribute it to geographically distributed processing nodes, like an edge node close to a machine, for instance. And there's currently a branch already with a proof of concept where you can select to which processing node you would like to deploy a pipeline element to, and then it gets transmitted to that node and is being started there, which is a very nice extension. We are working on a StreamPipes client to create pipelines from code and also to have a better view of existing data sources. So that will be part of the platform services, which is more like an API to interact with live data, historical data, and also to trigger start and also other operations on pipelines. And then we are currently working on some things for improving fault tolerance and pipeline monitoring. That is also partly already finished and will be part of the next release. So for pipeline monitoring, you get a better picture on what is currently happening. Are there any errors? How's the lack of processing state for each pipeline element and so on. So that's like just a quick overview of what we're currently doing. So yeah, if you want to get involved, so we really welcome new users. So if you would like to help, there's a large variety of open issues and a small variety of bugs. So there's a lot of things where we actually need your help, and your help is highly appreciated. So whatever you would like to develop, there are many things that can be improved on the UI level, on the back end, more pipeline elements and so on. So there are a few things like mailing list and the Slack channel where you can get help and also ask your questions, or in case you have any feature requests, you can also contact us there. And it's a really cool community that is very open also to new users. So we have a lot of first, let's say, easy to fix issues as well. Yeah, so that's it. You can find some links here, and we are at the end of our talk. I hope it was okay time-wise, and we are now happy to answer all your questions. Thanks a lot.
Yeah, thank you, Patrick, Dominic, and Phillips. So this is a great talk, and I know we are just 1 minute over. If anybody has some quick questions you want to, for three of them, and it's incredible, a great talk, and I love it. I love the UI, I love the design. So anybody have questions, you can ask now. And you can post the question on the Q&A session. I know this we're running over. Some people go to the meetings, but it's if you have no questions, thank you so much, all three of you. I mean, it's late from Germany. Give us the detailed talks from both the design and technical and all the deep dive. And I hope people will participate. I'm totally interested in this project, and I'll keep a close eye on it. It's